Welcome back to part 2 of the Pre-Calc 9.6 video. We left off from the first part talking about distinguishable permutations. We're going to continue that topic here. So I'm giving you the letters BL, BL, LBL, and I want you to tell me the different ways you can organize these letters so you don't repeat any of those patterns with them. So you have to deal with eliminating the duplicates. And that's really what this distinguishable permutations will do, is it will get rid of the duplicates for you. So you have to go over here and list out how many different B's you have. You have 3 different B's, and you have 4 different L's. So you take the total number of letters, there's 7 total altogether. So you'd put 7 factorial in the numerator, and you divide out the duplicates, 3 factorial and 4 factorial. So I would break down the 7 until I get to the highest number down here, 4. Leave that as factorial, so that the 4 factorial that is down here will cancel out, but I still have 3 factorial. And so when I do this, I get 210 in the numerator, 6 in the denominator, which will give me an answer of 35. So when you notice that you have the same object occurring more than once, in this case 3 B's, 4 L's, you have to divide out the duplicates by using this distinguishable permutation formula. Let's shift gears a little bit and now talk about a combination. So we've been dealing with in the first video permutations, and that's where order matters. Oftentimes you're going to see the word arrangement used to let you know that order matters. If we're dealing with a combination, we want to list out all the possible groups of the objects that we can come up with. And we're dealing with a group does not, order does not matter in a group. So if you see the word group, that's going to be your key that combinations is what you're doing. If you see the word arrangements, that's your key that you need to take the permutation of it. And you just ask yourself, is order important? So notice that for my example, it says my bookshelf can hold 3 books. How many groups are possible if I have 8 total? So I don't want to know how many different arrangements I can have, like the previous time we did this problem. I changed the word here to groups. So pay attention that if you pick book 4, 6, and 8, that's the same 3 books as if you pick them in a different order, 6, 8, and 4. I still have those same 3 books, so that's considered one group. I wouldn't count it twice, like I would if it was an arrangement. So we're going to use the combination formula here. You can use the formula or you can use the button on your calculator. This time your N, you have 8 books. You're only going to take 3 at a time. So it would be 8C3, which says 8 factorial over 8 minus 3 factorial times 3 factorial. So 8 times 7 times 6 times 5 factorial. I stopped at 5 factorial because I know that that was going to give me a 5 factorial over 3 times 2 times 1. So I get 336 divided by 6, which gives me 56 different groups of 3 of those books that I could take from the 8 total. If I wanted to, I could just type this right into the calculator and I can get the 56 also that way. I don't necessarily have to use the formula, I just show you how to use the formula. So pay attention to whether order is important or not, and that will tell you if you use permutation or combinations. How many different 5-person committees can be formed from a class of 20 students? So a committee is another way of saying a group. So you ask yourself, is order important? No. So if it's not, then we're going to use combinations. So because we're dealing with 20 students, that's the N, and we're going to take 5 at a time, that's the R, we're going to do 20 C5. And again, plugging this in the calculator, which is the method that I would prefer that you use, take the time to pause the video, type yours in, and see if you get the same answer as me. So if you tried it on your own, you should have gotten 15,504 different 5-person committees that you could form. A class consists of 8 males and 12 females. How many committees of 5 members are possible if the committee must be made up of 2 males and 3 females? So we're talking about a committee, so we want to ask ourselves, is order important? A committee is the same thing as a group, so this has to be a combination problem. Because when you get into a group or a committee, it doesn't matter if you're chosen first for the group or if you're chosen last for the group, you're still a part of that group. Order is not important. Now, as you deal with this problem, let's look at males and then females and figure out the total number for each of those. So from the males, I have 8 total males and I want to choose 2. So I'm going to do 8 combinations of 2. From the females, there are 12 females altogether and I want 3 females in my group, so I would be 12C3. And what I'll do with those answers is I would multiply them together to get the total possibilities of all the different groups that I could get. 8C2 ends up being 28. 12C3, again using the combination button in my calculator, is 220. And when I multiply those two numbers together, I get 6,160 different groups. So I knew I had to use combinations because it says the word group, and group does not mean order is important. Next one, a combination lock will open when the right 3 numbers from 1 to 40 are selected. How many different lock combinations are possible? So I would choose for this one to use the counting principle, because here's what I'm thinking when I do this problem. I got a 3-digit number for my, I shouldn't say 3-digit number, 3 different numbers that I plug in to make my combination. And order is important on a combination lock. So order is important, so I'm not going to use combinations, and I'm even not going to use permutations at all, because I think the counting principle is going to be a lot easier. So I've got the numbers 1 through 40, so that's 40 total numbers. And on a combination lock, you can repeat the digits. You could have the same 3-digit com, so you would ask yourself how many different numbers could you put in for the first number? There'd be 40 different numbers, and the second one would be 40, and the third one would be 40. So we do 40 times 40 times 40, and we would get 64,000. So here's a math joke for you. Shouldn't they call a combination lock really a permutation lock? If you're not laughing out loud, I know you're at least laughing inside.